Let's talk about conditional branching. Conditional branching allows for different sequences of pseudocode to be selected and run based on the result of Boolean expressions. Let's take a look at this pseudocode here. We see that there is a Boolean condition and the if statement just before it. What happens here is the Boolean expression is evaluated, and if the result is true, we will execute the lines of pseudocode which are indented and underneath the if statement. However, if the Boolean expression is false, we skip the indented line of code and we go to the lines of code indented and underneath the else statement. So let's check this out by walking through the example and using the trace table. We assign -1 to x. We then evaluate the Boolean expression and we find that the Boolean expression is true. So we are going to go into the line of code which assigns -x into y, which gives y the value of 1. Let's repeat that example with a different initial value for x. This time we're assigning x to 1. We evaluate the expression and we find that the expression is false. So we go down to the else statement and we execute the line of code that is indented and underneath that. Y here is assigned the value of 1 also. If we were to repeat that sequence of pseudocode and have the value of x take on every integer from -5 to 5, so we repeat that 11 times, we get the following table of values, and if we were to plot that, we would see the modulus function. Within the if and else statements, we can have multiple lines of pseudocode indented, and when this happens, we just go through and execute each of them. This example, we assign 1 to x, and if we plot this for all values of x between -5 and 5, we see that this is a plot of y is the modulus of x translated 1 unit in the positive y direction. If we have any lines of code which are unindented underneath if and else sequences, those lines of code are always executed once the if sequence is completed. So the if sequence can be considered as all the lines of pseudocode which are part of the if and else statements together. So we start off by assigning -1 to x, we evaluate the condition, we assign y as -x. That means the if sequence is now complete, so we go to the next unindented line of code, which is y is incremented by 1. Similarly, if x was assigned the value of 1, the condition is now false. We evaluate the lines of code indented and underneath the else statement, and then as before, we execute all the lines of code that are unindented after the if sequence. So repeating that pseudocode for all integers from -5 to 5, we see that that also plots the function y is the modulus of x plus 1. And you can see the pseudocode on both the left and right hand side produces the same output. And in this case, it works because the pseudocode that assigns y to y plus 1 on the right hand side is repeated for both the if and the else conditions. So that line of code is always going to be run regardless of the result of the Boolean expression. We're going to take that out unindented and put it after the if sequence. It's important to note that we don't require an else statement after an if statement. We start off by assigning x to -1. We evaluate the Boolean condition. And if it is false, the if sequence is complete, even though this if sequence doesn't have an else statement. So we go to the next unindented line of code. Y takes on the value of -1. Here is what happens if x were to start off at 1. So if we plot this for every integer from -5 to 5, we get the following plot. And finally, if we do have an else statement, it must have an if statement before it. If we just had an else statement sitting by itself, that would not make any sense because it requires a Boolean condition to be evaluated before it. So that's a quick overview of how conditional branching works in pseudocode.